This video, we are going to continue our discussion of section 14.7. This is triple integrals and other coordinates. So in this video, we're going to focus on spherical. Here's a reminder of what spherical looks like. We have 3 points. We have rho, then we have phi, and then we have theta. All right, so phi is not a radius. We still have a radius here in our picture, but rho is not the radius. The rho is going to be the distance between our origin and the point in question. So that's rho. Phi, and I'm going to write this out, phi is always between 0 and pi, one of those. And it's from what it is, and we talked about this earlier this semester, it is the angle from the positive z-axis down to our rho. Usually we keep that in our yz plane. You'll see that in our example below. And then the last thing is our theta, which acts just like polar. It's the rotation from the positive x-axis in the xy plane. All right, there is a, for this, let me go ahead and start writing what this conversion is. So we got theta, we got phi, we got rho, and then we're going to take this, and I'm going to save some room here. Remember, this is us putting it in different form in x, y, z. This would be using this stuff right up here. Those are quotation marks, just my pen's not doing it very well. All right. And then here is the conversion that doesn't make sense, that'll make sense next section. Just like the other one we added in R, we're going to add a rho squared sine phi. And then we got d rho, d phi, and d theta. We get all 3 of those. So this is our special conversion thing. This is our new R. But going to cylindrical, this is what's called a Jacobian. We'll be talking that in 14.8, so it all makes sense where those come from here in another section. But for now, you just got to trust me that that's what we add in. So let's get a couple of examples under our belt. There is a couple things to do here. I'm going to write some notes. To bound rho and phi, let x equal 0. To bound theta, just like last time, we let z equal 0. So let's do that first. All right, letting x equal 0. All right, well, that's what we're going to do here. Let's, first I'm going to bound rho a different way. Since I only have one equation here, what I'm going to do is notice what this is. This left-hand side is rho by definition. So this is rho is less than or greater than 1 rho squared, which means rho is less than or equal to plus or minus 1, but we're just going to put a 1 here. Rho is always positive. All right, so what that does for us, and we can get a couple of different ways. I'm going to let x equal 0 so you can see how this works out in the same way. So if I let x equal 0, I got y squared plus z squared is less than 1. Okay, what that is on my graph. So let's do this. This is my z, this is my y, and I'm going to bound this, and it's going to help us out. And once we draw the picture, okay, this is just a circle with radius 1. So there's my circle. It corrected interestingly. I'll go smaller here. My bad handwriting. All right, so the radius is 1 here. What this is going to help me do is it helps me find a rho. Rho is established this way, meaning, okay, I do the same thing I did for R, but now I go out, and I know now rho is caught between 0 and 1. Right? I have that, and then now I can use that same graph to find my phi. Now, phi, how it's going to work is it's the angle, and I'm going to draw from here out to that. So this is what phi is going to be, and we use this graph in the yz plane to determine that. That is phi. So I'm looking at my circle, and I want to go, remember, phi is only between 0 and pi. Well, this goes all the way, this goes all the way through, right? It covers, I keep hitting my eraser. It goes all the way through. It doesn't go past pi, but it hits all the graph. That's what this is, right? That is that circle. The circle tells us that it goes from 0 to pi. Now, the interesting thing that will be here is you got to determine from that top angle. So this is 0 to pi, right? And then the last thing is theta. To do theta, it's the same as we've been doing. You let z equal 0. So I'll do that right here. Z equals 0. That implies that x squared plus y squared is less than 1. This is a circle with radius 1. So that goes from 0 to 2 pi. So to find rho and phi, you let x equal 0, which gave me these two equations. Both of these equations lead to that circle that I have there. The problem is rho less than or equal to 1, maybe you didn't picture it in the YZ plane. Well, that's where we're going to let rho live. All right, so our setup here, and we're just going to, this is going to be the only one we work out. The rest of them will be setups. All right, so this formula, right, we're up here. We got the triple integral. So from theta, phi, let me write this a little bigger. Spread them out, meaning, okay, theta is 0 to 2 pi, phi is 0 to pi, and then rho is 0 to 1. We got to replace that whole inside. That whole inside there is equal to rho. Rho squared, and then the square root of rho squared is rho. And then I got to replace or introduce, this is the r, the Jacobian that we're going to talk about soon. Rho squared sine phi, and then d rho d phi d theta. All right, we're going to work this out. All right, so we got our phis first. I'm going to go ahead. I'm not going to rewrite the whole thing. That is just a phi cubed. I'll rewrite my bounds for the other ones. And then this is going to be 1/4 rho for sine phi. Rho is 0 to 1. All right, so I'm going to plug all those in. What's really nice about this is that rho equals 0 is just going to get rid of it. So we get, okay, so theta from 0 to 2 pi, phi from 0 to pi, and then plugging that in, I got 1/4 sine phi, d theta. All right, I'm going to go ahead and do that integral. All right, we got 1/4, and then it's going to be a negative 1/4 because of cosine. And then we're going to run that from 0 to pi with the d theta left. All right, we're almost there. Oh, and I almost made a mistake. This is phi, not theta. This is phi, not theta. There we go. Caught it before we did it. All right, cosine of pi is going to be, okay, I got negative 1/4 times, okay, and then cosine of pi is negative 1 minus, and then I get negative 1/4 again, and cosine of 0 is 1, so that's what we get. That is a positive 1/4 plus a positive 1/4, which gives me theta 0 to 2 pi, and inside is just a 1/2 d theta, which is going to leave me with a pi once I integrate. All right, so the integration shouldn't change. I'm only going to do one all the way. These other ones we're going to set up because that is the most difficult part, is the setup. So I have one more example for this video. All right, so this one we're just going to set up. So set up. All right, so the first thing I'm going to do is I have my region bound by that and the xy plane. I can go ahead and convert, or let's go ahead and do it the right way. To bound the z, or the phi in this case, we're going to let x equal 0. So letting x equal 0, we get z equals the square root of 1 minus y squared. If I work that out, I get z squared plus y squared equals 1. So this is a circle in the YZ plane. All right, so there's my circle, good enough. Sorry for the shakiness in my hand. So this has a radius of 1. So now I'm going to use this to grab my rho. Right, remember rho runs from here to here. Right, and that tells me that rho then is caught between 0 and 1. Right, remember I can pick up phi this way as well. Our phi is going to, and it says in the xy plane. So if it's just the xy plane, we're just talking about this portion. All right, so that's the XY plane. It keeps it over there. So that means that phi is caught between 0 and then that angle from the top is pi over 4. Sorry, pi over 2. Oh, it's both of these regions. That's going to be our XY plane. So right, so hold on one sec. The pi over 2, if we do, forgive me. Let me think about this for a moment. We're running from, okay, I know this is going to be pi over 2. I know that from my notes. We are running, talking about phi, so that's this angle from the top. And if I think about phi, it's running from z. Remember, x is coming out like this. And we're saying we're going to bound it between the xy plane and that function. All right, so that means that it is just this top portion. All right, yeah, this makes sense. If my phi is running from here all the way and it stops right there, that is pi over 2. All right, so there's my rho. XY plane is flat. That's why I drew this picture here to understand what's going on here. This is just saying above the XY plane, so it's only the positives. What I did here is I just need to know from the Z down to the XY plane. It was confusing for a moment because you almost want to call it pi because of this, but that has nothing to do with phi. Phi is from the positive Z down to the XY. So that's 0 to pi over 2. And then the last little bound we have, okay, this is a bit confusing because now you have that. We don't care where it's at. We just want to look down on our xy plane. If I let z equal 0, I got 0 is the square root of 1 minus x squared minus y squared. And plugging, if I work that out, okay, if I square both sides and move things to the right side, I got x squared plus y squared equals 1. All right, that is a circle. Now, this is in my xy plane. This doesn't matter if we just need to look, does it go all the way around? Well, think about this. This is some top of a sphere. On top of the xy plane, we need to go the full revolution around. So it's 0 to 2 pi. So let's, because I kind of stopped there for a moment, let's talk about why we did things. Now, we know to get our bounds for rho and phi, I let x equal 0. That established what we have there in the y plane without these. So we could take these out. That's the yx plane. We established that that's a circle. We also know xy is flat there with the y, so I know it's only the above circle. And that's due to this, the xy plane up here. So since that is that way, it covers only the top of the circle. I know that rho is 0 to 1 because we see that here, right? We have this 0 to 1. And then the purple line establishes how much phi we need. It only goes from 0 to pi, so we don't have to worry about that other side. What captures the other side is that we spin theta around, all the way around. It'll capture this area over here. All right, so our setup. So did they say volume for this one? No, they had an integral. All right, the integral was y dv, and then t, and set up the way we have. So, okay, so we get triple integral. All right, we get theta is 0 to 2 pi. Phi is 0 to pi over 2. And then rho is 0 to 1. The inside was a y, so I replace that with a rho sine phi sine theta, and then we get the things that go along with switching to spherical. Rho squared sine phi d rho d phi d theta. Once you work this out, it equals 0. This is probably, and this is most of the case, most of the time, that we're dealing with net volume, meaning negative. We take negative volume, just like there was a problem in Calc 2, finding like sine from from, what is this value? Sine of negative pi all the way to pi, these cancel out, right? So we're just dealing with that same idea, but in 3 dimensions. I have things that are lower than the z-axis that may cancel out. So how we can deal with that, and a lot of textbook problems are this way, and they'll leave it at 0, But let's say I was actually not wanting to find net, but like actual volume. I could take this and do theta equals 0 to, instead of 2 pi, we could do pi and times by 2. If that doesn't work out, then what we could do is go from theta, should be an equal sign, not a plus, theta equals 0 to pi over 2 and multiply it by 4, right? I could do, those are a couple techniques in Calc 2 to help do that. If you get a 0 when it's supposed to be a 0, I'm not going to do anything like catch the volume, not net. We're just going to only do nets. So if you could work this out and get down to 0, you'll be set. Now, like I said, most of this on our tests or exams will be set up. I will probably have you work out some, but a lot of it will be set up. All right, we'll just cover, okay, I think I have one more problem I want to add to this video. All right, we're going to set up another one. Actually, we'll go ahead and just do all 4 here. Perfect. All right, so we're going to evaluate this one. A couple things I want to notice. This is a sphere. This, and this is the hard one, and you'll get used to this. This is a cone. So what we're going to do is let x equals 0 for both, right? That's how we're going to bound rho and bound phi. So if I let it, I got y squared plus z squared equals 4. And we have z equals the square root of y squared. Now this is tricky. Think about plugging a y in. If I plug a negative y in, it becomes a positive y, the answer, right? And I know you're tempted to write this. That is not true. This is true. Absolute value. All right, we're going to bound this now in our picture. The first part is a circle in our YZ plane of radius 2. So there is my circle in the YZ plane. Now this is our cone, right? And it goes up through here and up through there. So what we're actually trying to find is this region right here. So let's, we can bound rho. Rho starts, remember we start at the middle and just work our way out. So if I put a point here and work my way out, that's where I'm at there. So actually rho is bound between 0 and 2. That is the radius of that circle. Now the angle maybe is not so apparent. We're from here going out and we're going to there. Now since this is literally y, right down the middle, x equals y or z equals y, rather z equals y, that angle is a 45 degrees or pi over 4. So I know that phi is caught between 0 and pi over 4. Right? And then remember to get our last one, we let z equal 0. Let z equal 0. This will find my bounds for theta. So if I let that, I got x squared plus y squared equals 4. Okay, that's just a circle with radius 2. So I know theta goes all the way around in this case. Nothing tells me it doesn't. It goes from 0 to 2 pi. So we're just going to set it up. So this triple integral over t of xz dv. We got the xz. That's just the problem they gave us. Set all this up. Right? Theta is between 0 and 2 pi. Phi is between 0 and pi over 4. And then the last thing, rho, is between 0 and 2. And then we're going to replace x. Okay, x is r cosine theta. I wrote phi, but I meant theta. There we go. Sine phi. And then z is rho. Rho cosine phi. And then we get the Jacobian there, which I'm giving it a name, but it's the part that we got to remember. And then d rho, d phi, and d theta. Right, if you want to practice and work this out, this one actually equals 0 as well. I would recommend practicing. I say this in some of the videos. In the test, you're going to do a lot of setup only, but here's the deal is you're going to need all this stuff. You're going to need to be you're going to need to be really great at integration for DiffEQ. Those of you that are in DiffEQ at the same time, you know what I'm talking about. It's just so much integration, so get the practice while you're here. And you already have to do this for me for homework. Might as well practice the integrals while you do it. You know you're not going to have to do a lot of them on my test. You only have to do a few here and there, or they'll be doable. There won't be any of this crazy do 10 problems of this, right? And work all this out down to that. You just don't have time. So I'll have you work some out, some you won't. All right, we got one more. This one's a bit tricky, but all this kind of sums it up pretty quick. The hardest part is regions. So the first thing we're going to do is let's try to bound rho. Okay, I'm going to identify a few things. Z equals 2, that's a plane. It's just a flat plane at z equals 2. And then this thing is a cone. I would get used to seeing the cone. It'll help you a whole lot with setting these regions up. So x equals 0. Okay, well, z equals 2. I still have that. And then if I let x equals 0, I got z equals the square root of y squared. Remember, that's the absolute value of y. So on my picture, all right, I have z equals 2. So let's do this. This is y. This is z. We have z equals 2, 1, 2. And we know it's a flat line running through there. We also have this cone that runs through it as well. And we're talking about the region here. All right, the rotation for our theta will take care of that other side. All right, so we have that. Now here's the problem is for rho, if we're trying to establish rho, let's go ahead and write that. Rho, and we're going to try to bound it. We have from the origin, okay, that's our first point. So we know it's going to be a 0. But we have to figure out where it's going to. Now the problem is here is this distance is different than this distance. They change. It's not, I can't just say from 0 to 2 because that's z, that's not rho. So I got to figure out a way to manipulate this. Now, remember that z, and we're going to work from here, and I'm going to try to put it in terms of rho. Z is in spherical rho cosine phi. So I can just replace z with that, and then if I solve for that, I got 2 over cosine phi, and then we know over cosine is secant. So I know that top one is 2 secant theta. So I know that rho is caught between 0 and 2 secant theta. All right, then we need phi. Well, we can tell from the picture, and we already had one like this. This is 0 to pi over 4. It's going to this diagonal here, and that's right down the middle. And then the last thing we have is theta. Okay, well, if I take my two equations here and set them equal to get rid of z, remember we let z equal 0, or we can set them equal. I got this. This gets me 4 equals x squared plus y squared. All right, that's a circle with radius 2 in the xy plane, so that will give me this, 0 to 2 pi. So now we set it up. The volume is equal to, okay, I'm going to set my integrals up. Theta is 0 to 2 pi. Phi is 0 to pi over 4. And then theta is 0. Oh, we just did theta. Rho is 0 to 2 secant theta. I know this seems like it's going to be absolutely horrendous to plug all those in. It actually works itself out. Nothing past a U sub. So setting this up, it was a 1 inside because it's just volume. Now this is that part I have to add for cylindrical. And then we have d rho, d phi, and then d theta. If you work all this out, which I recommend, you get pi over 3. Again, this is all about setup. That's where we're headed. You have a few more sections that are going to be like working things out completely, but most of this will be like, here's a quick way to solve this integral, and then we'll take a look at it. All right, so that covers all of this section.